Alright, pre-calc students, this is the final exam review for the multiple choice final. So, this has been online for a while, but let's just go through it. So, number one here. A ladder is leaning against the side of a house. The base of the ladder is 6 feet from the wall and makes an angle of 48 degrees with the ground. Find the length of the ladder. So, 48 degrees with the ground means that angle is in the corner over there. Ladder is 6 feet from the wall. That's this distance along the bottom. Now, what do I want to know? I have two sides that are unknown. I want the length of the ladder, which means hypotenuse. So I know something that's adjacent and hypotenuse. That immediately screams to me good old-fashioned cosine. So the cosine of 48 equals 6 over hypotenuse. And then you solve for h. You can either multiply by h and divide by cosine of 48, or just flip-flop cosine of h right there. Make sure your calculator is in degree mode here. Number 2, write the decimal value of sine of pi over 7 to the nearest thousands. Okay, your calculator is in degree mode for number 1. It needs to be in radian mode for number 2. It's a straight calculator mash. No issue whatsoever there. Reference angle. Reference angle is the angle that, if you want to think of it this way, that gets you back to 360. So, 360 minus 290, 70. What is the period of the function 2 cosine of 4x minus pi over 2? Remember, the period of a function is 2 pi over beta. Beta is b there. That's the b value. It's 4. It's 2 pi over 4. It's pi over 2. Identify the angle in degrees. It's a cosecant equals secant here. All right, well, cosecant is just 1 over sine. Secant is 1 over cosine. I can take these two things and flip-flop them right away because I can take the reciprocal of both of them. If I take the reciprocal of one side and do it to the other, we're fine. So take the reciprocal there, and we're good. So then I look, and where is the cosine equals sine? That happens at 45 and 225 degrees. Why doesn't it happen at 135 and 315? Because you might say, hey, they're both root 2 over 2. Yeah, but one's negative and one's positive. Here in 45, they're both root 2 over 2. Here, they're both negative root 2 over 2. All right, given a triangle ABC with measures A, B, and C, measure of angle A is 35 degrees, side A is 1.5, and length side B is 0.4. What is the measure of angle B? All right, so I set up my diagram as such, and I look and go, okay, I would love to use the law of sines, and I can here because I know angle A and side A. Remember, we talked about the ambiguous case of S, S, and A. So when I do this, I do the sine of 35 over 1.5 equals sine of B, which I don't know, over 0.4. I solve for the sine of B. Take the inverse sine of that, make sure your calculator's in degree mode, and I get 8.79 is my side length there, or my angle length. My angle length there. Now, check for second triangle. I take 180 minus that. That's 171. That can't happen because that's already 35 degrees. You won't usually see those a lot, but you do have to make sure that there aren't two angles there. All right. Given triangle KM with the sides N, 5 inches, M 12, and K 9, what is the measure of angle K? So I found angle M first because I can, using my wonderful and glorious law of cosines. And then, once I know M, I can set up a ratio between angle M and side M, and angle K, which I don't know, and side K, and give you my angle there. Now here, for number 8, solve the following equation for all values of x in radians. So you can do it two ways. You can factor out a sine of x, that's GCF, then factor this, difference of squares, and then set each of those factors equal to 0, where sine equals 0 at 0 and pi over 2, where sine of x equals 1, pi over 2, where sine of x equals negative 1, 3 pi over 2, or you simply set that equal to 0 as well, remembering the plus minus when you square root, and you get the same answer anyways. Convert 4 pi over 3 to degrees. You simply multiply that factor of 180 over pi, which becomes 180 over 3 is 60 over 1. 6d times 4 is 240. Pi's go away. Convert the angle 510 to radians. That means this number should get smaller, so we take pi up top, 510 divided by 180. Cancel out the zeros, you get 51 over 80. Divide this by 3, 17 pi over 6. Alright, given this value here, sine is 4 over 5. Alright, opposite 4, adjacent 5. But the angle is over here in the second quadrant. That means that my x is negative. That's negative root 3. So what's tangent? Tangent is opposite 4 over adjacent negative 3. So negative 4/3. Alright, here, first quadrant, plus plus. They give me cosine. That's opposite. No. Adjacent? Yes. So, unlike the previous one where it gave you opposite, now it gives me adjacent 4 over hypotenuse 5. Pythagorean theorem to find that side is a 3, Pythagorean triple. And they want sine, that's opposite over hypotenuse, 3 over 5. Cosine, the max value is 1. It goes from negative 1 to 1, usually. Max is 1. Find the minimum value here. Sine of x, usually the lowest value is negative 1. Now I add 2 to that. Negative 2, or negative 1 plus 2, 1. Unit circle here. Tangent of 300 degrees, it's negative root 3 over 2 over 1/2. Multiply by the reciprocal here. You get negative root 3. Done. 16th straight unit circle problem. Look at your unit circle, what you have given to you for 300 degrees, and you find that. 1 minus sine squared of x. That is a wonderful Pythagorean identity. Sine squared plus cosine squared equals 1. So that would be cosine squared, because I can modify this identity there. Given a right triangle whose hypotenuse is 13 degrees, if one of the angles is 55, find the length of the opposite side. If they want opposite side, no matter where you put that angle, the opposite side is going to scream to you the following. It's going to scream to you, I'm using sine. So sine of 55 is my opposite that I don't know and want over 13. Multiply by 13. 13 times sine of 55 degrees. Again, you need to be in degree mode. Straight calculator problem from there. What is the 10th term defined by the sequence? All right, you just put 10 in for n there. They give you the explicit formula. You can just throw 10 in. That's what's great about explicit formulas. Find the first 7 terms of that sequence. You literally just put in 1, 2, 3, 4, 5, 6, and 7 in for n there and do the math work. All right, what is the difference between an arithmetic and geometric sequence for 21 here? Arithmetic has a common difference between the consecutive terms, and geometric has a common ratio between the common consecutive terms. You could also say arithmetic has a strict adding, whether it be adding a positive or adding a negative, and geometric is a strict multiplication, whether it be multiplying by fraction or not. 22, provide one example of arithmetic and one example of geometric, also an example which is neither. Folks, this is an example of, but not limited to. As long as you have a strict adding pattern, like I'm adding 3 for here, you have an arithmetic. You could add a negative 7 every time. You could add a fraction every time, like add 1/2, 1/2, 1/2. As long as you are adding the same value, whether it be positive or negative, it's arithmetic. For geometric here, I'm multiplying by 3 this time. Again, geometric, you could simply have a strict multiplication pattern. Like, hey, I'm multiplying everyone by 1/2. I'm multiplying everyone by 7. As long as it's the same, you're fine. A neither is you need to have a pattern which has no pattern. The pattern is there isn't a pattern. So in this case, obviously these fractions are the same. I'm not adding the same thing. They're multiplying by the same thing. So in another example, you could be add 1 and then multiply by 12 and then divide by 17. That works. All right, here, 23, find that. So you can either find each term and add them together, because it's from 1 to 7, so find the first 7 terms and then add them. Realize that the arithmetic sequence, because it's just a straight adding pattern there, that would be, well, n plus 1/2. So you find the first term and last term. First term is 3/2, the last term is 15/2. You add them together using your arithmetic formula, which you have in your formula sheet, and get there. Or you can use summation form. We talked about that a little bit. You also have those using your summation keys there. Option 4, also I didn't put on here, is just straight calculator problem in MASH. Here, this problem, you can use, again, your summation, number 24. The answer for 23 is 31.5 either way you look at it. 24, you can either use your wonderful and glorious summation formulas or realize it's arithmetic too. You could also find the first 21 terms and add them, but that wouldn't be very beneficial. Or straight calculator problem. 25. The first term of a sequence is 4 and the common difference is 6. Okay, first term 4 means a sub 1 is 4. Got it. Common difference. Common difference means, holy cow, I'm getting myself an arithmetic here. So when I do that, which is great, I have my arithmetic formula, which is, again, you have on your formula sheet. A sub 1 plus n minus 1 times your common difference. Common difference is 6. First term is 4. Then distribute the 6 here. That means 6n minus 6. Combine your like terms. Now, I put the n first. You don't have to. 26. The first term of a sequence is 2. Common ratio. Ratio means geometric. That means first term times your common ratio to the n minus first power. That is your geometric form, which you have on your formula sheet. All right, 27 is a sequence is defined as follows. Find s sub infinity. All right, well, that means my r is 1/3, my first term. How do I find that? They don't give it here. Put in 1 for n, because that's your first term. Gives me 1/3. You put it into my s infinity formula, which I have, again, on the formula sheet. 1/3 over 1 minus 1/3. And do your math from there. You get 1/2. Okay. Use the diagram below the following. Find the value of angle A. Uh-oh, I know no other angles here, but I know all the sides. That is law of cosine. Now, it's important. Notice side A is across from angle A. It's 15 right there. That means that in my formula, if I'm looking for cosine of angle A, that side A must be across from the equal sign. These two are irrelevant where they go, really, because you're adding them together or you're multiplying them in this case. So it doesn't matter the order, but it does matter where you put 15. If you're looking for an angle, its corresponding side, which is directly opposite for it, must be across from the equal sign. And again, calculator must be in degree mode here. Okay, so I know angle A. Find the value of angle B. Well, you can do it a couple different ways. One, you can go, listen, I know what angle A is now. I know side A. I can use law of sines. Yeah, buddy. So, I use angle A, sine of angle A, over side A, which is 15, over sine of angle B, which I don't know, over 14. And then inverse sine for that. You could also, if you don't trust that you've got 28 right, you can go back and use law of cosines again, knowing full well that this time the 14 will be across from the equal sign. And 30 here is kind of interesting, because 30, you've got some options. 30, you can go 180 minus the two angles I just found, or use law of cosines again. All right, so the triangle is right. Find the value of x. X is right there. It's hypotenuse. I know opposite and its angle. So the sine, since it's a right triangle of 30 degrees, equals opposite over hypotenuse. I don't know hypotenuse, so I switch these two things. So x equals 5 over the sine of 30, which means 10. Find the value of y. Now, you can do this a couple different ways. You could use tangent and do tangent of 30 equals 5 over y, or since I now know what my hypotenuse is, you can go cosine of 30 degrees equals the 10 I just found for x, which is my hypotenuse, and do it this way. All right, cosine is adjacent, I don't know it, y, over hypotenuse, 10. Multiply both sides by 10. Cosine of 30 times 10 is that value right there. Find the value of angle B. That's really easy because angle B, if I only knew the other two angles, well, one's a right angle, which makes it 90. The other one is 30, which is that one right there. Done deal. You're just spinning a yo-yo at the end of a string. That is the arc length formula. Only thing you must do is you must convert 540 into radians, which is 3 pi, and then it's a straight formula problem. Find the exact value of, which you have in your formula sheet, by the way. Cosine of 75 degrees. You split it up. Now, I split it up with addition here. You don't have to. But I did. I did 45 plus 30. There's my alpha. There's my beta. Straight formula. And then unit circle. Angle B. Fairly simple here. 180 minus those angles. Side B. Law of sines.